Welcome, ladies and gentlemen, to this video lecture. Let's take a look at this example. So we want to determine the length of this curve C as given. And if you think a little bit, what is this curve? It is a parabola. So we want to determine how long is this curve when x is in the interval 0 to 1. Okay, all we will do is we will use the definition of arc length. So let's define f on the interval 0 to 1, and we define f of x as a half x squared. Derivative of x is then x, and so the length, let's say the length L of C is as follows. So the length L of C is the integral from 0 to 1 plus the square of the derivative of f, so x squared dx. Okay, and now this is half of the battle is done. Now we just need to compute this integral. This integral is tends to be quite, or is a little bit tricky. There are some tricks involved. So let's make the substitution. The substitution theta is equal to arctan x. So what I'm going to do is I'm going to apply tan on both sides. So tan theta is equal to tan of arctan is just x. Okay, and let's work out dx d theta. Dx d theta is derivative of tan, which is sec squared theta. So if we do the substitution, what do we get? We get square root of 1 plus x squared, but x is tan theta. So what do we get? We get tan squared theta multiplied with the dx is going to become a sec squared d theta. Okay, and the bounds, if x is equal to 0, theta is going to be arctan of 0, which is 0. If x is 1, theta is going to be arctan of 1, which is pi over 4. Okay, and now we use the identity that 1 plus tan squared theta is equal to sec squared. This is equal to sec squared theta, sec squared d theta, and on the interval 0 to pi, what do we see? Let's just think about the cosine. Cosine looks as follows. So there we've got pi, there we've got 2 pi, here we've got pi over 4. So on the interval 0 to pi over 4, no, sorry, that is pi over 2. So pi over 4 is over there. Everything is positive. So what do we get? Integral from 0 to pi over 4. We get the absolute value of sec theta but since everything is positive on the interval from 0 to pi over 4, we can forget about the absolute values, and multiplied with that sec squared, we get the integral of sec cubed. Okay, and this one is also a little bit tricky. The hints, or there is an example given in the textbook. Let's take a look, or do take a look at example 4.2.12 on page 191. And then if you compute this integral, finally we get then square root of 2 plus 1 plus square root of 2 all over 2. So there's a little bit of work involved here. Do take a look at the example on page 191. Okay, point is, the length of this curve is that. And here we have the exact answer for the length of that curve. And that is it for this example. I will see you in the next one.